Welcome, I am Kevin King. In this, the third of our series of 6 training videos, I will introduce the user screens for our inter-row guidance system. Other videos in this series take you all the way from how our systems work through to creating configuration files for crop or machine geometries that you've not already got stored preset configurations for. You can select the video you need from our website and view it as many times as you want. The same material is covered in rather more detail in our reference manuals, which can be downloaded from our website. The Inter-row reference manual is available in English, French, Spanish, Polish and German languages. First, you'll need to power up by pressing and holding on the button until the LED lights up. You will then need to wait a minute or so while the PC inside boots up. Once this is done, you will automatically go to the home screen. The touch buttons on the right reflect the options available. For an inter-row machine, the top button will be the inter-row symbol. If the machine can perform additional functions, for example within row weeding, there will be additional buttons with extra application mode symbols. Below the inter-row symbol is the configuration file editor button. You do not need to access the editor in normal running. More on that in training video 6. Below that is the Service Tools button, which gives you access to a variety of tools that can be useful in maintaining or fault finding a system. These will be covered in training video 5. Finally, at the bottom is the Power Down touchscreen button. To start inter-row guidance, touch the crop row symbol button. The button will go brighter and the function is actioned as the finger is removed. You will be taken directly to the inter-row guidance working screen. It is possible to apply your manufacturer colours to the working screen on request. This is the working screen. It features a live video image with template and tracking crosses overlaid. A green dot or green chevrons below the image indicate side shift or disteer position. A red chevron with a vertical bar indicates the limit of travel has been reached. This should not be allowed to occur for extended periods. A fine offset gauge on the right shows the amount of left or right bias set by the user. This can compensate for minor lateral camera misalignment, crosswinds or side slopes. By default, the fine offset has 6 1cm steps in either direction, though the number and size of these steps is configurable. A speed gauge on the right displays forward speed, which should match tractor speed. By default, the speed bar is green up to 11 km per hour and red over 15 km per hour, which is a normally sensible operating limit, though guidance will continue at higher speeds. But for some applications, this speed scale can be reduced to suit the application. An image quality gauge to the left of the screen gives a relative indication of likely tracking performance. The higher the green bar, the better. A low bar indicates either poor template match or poorly defined crop rows. Guidance will, under most circumstances, operate down to an indication of approximately 20%. The button labelled with a camera to hand icon is used for toggling guidance mode. Manual mode can be used for setting up camera geometry and operator manual control of the implement. The icon displayed on the button reflects the currently active mode of operation and the next mode that can be toggled into. Depending on connected hardware, this can also change the available modes of operation displayed on this button. If a manual override has been connected and is turned on, this will show a hand symbol indicating that the manual override input is active and no camera guidance input will be used. Toggling the switch of the manual override back to the off position will return the guidance system to the previous mode of operation. If a feeler override canvas device has been connected, this will be added to the sequence of available modes and can be pressed to toggle into the manual and feeler input modes of operation. To access the manual mode settings and preferences screen, touch and hold on the mode selection button. From this pop-up menu, you can change how the system responds to various situations to suit your personal preferences. The first setting allows you to toggle the machine to centralise the side shift or steering discs upon entering manual mode. Touching on the corresponding toggle switch will enable you to activate or deactivate the selected option. If you go into manual guidance mode from the working screen, our system will by default automatically jump into the vision guidance mode once it starts moving. You can change this so that it requires the user to actively reselect vision guidance mode with this setting. By default, our system will always try to find rows to follow, no matter how difficult that is. This policy can allow guidance in some surprisingly difficult situations. However, some users prefer our system to give up somewhat earlier, so that they can deal with the situation manually. This option enables that behaviour. The threshold for adjusting this behaviour depends on the level of uncertainty. The lower the uncertainty threshold, the sooner the system will enter lost mode. And the larger the threshold number, the later the system will enter the lost mode. If auto resume has been toggled to on, tracking confidence is monitored while the guidance system is in the lost mode. Once the level of guidance uncertainty has risen to a suitable level for enough time, camera guidance can automatically be resumed. If feeler override ones are connected and activated when they make contact with the crop row, this preference allows automatic engagement of feeler override input to control guidance. The bottom left corner is reserved for warning and system status symbols. An implement lift symbol is displayed when the lift signal is received. A circular red brake symbol is displayed if the implement is down but not moving. A warning triangle indicating poor tracking is displayed if estimated lateral error exceeds 25 mm. On seeing this warning, users should check performance on the ground. If enabled, the warning triangle will be accompanied by an audible warning. A thermometer and microchip indicates that the console motherboard is overheating. This should not be allowed for prolonged periods of time, as it may cause damage to the processor. Open circuit and short circuit symbols indicate issues with the valve connection. In order to reset this error, the system must be powered off and restarted. A warning triangle with the letters CAN indicates a CAN bus communication failure. View the error log and the hardware map to further diagnose individual CAN bus device status. There is an optional facility for selection of crop colour for guidance. If this feature is active, a plant symbol will be displayed towards the top left of the camera live image. Pressing on the plant symbol will bring up a pop-up selection menu, allowing selection of crop colour to suit the application by pressing on the applicable tab. The icon displayed also represents the currently active colour selection of green, red, and also green and red crop colour. This setting being useful in crops that have a mixture of red and green foliage. There is also the option available for custom colour operation, but this is generally not active as standard, as most situations can be covered by the standard colour options mentioned previously. If custom colour option is active, there is the facility to adjust the crop colour using the plus and minus buttons on screen for fine adjustments, as well as touching on the colour spectrum band to select a colour setting. But it must be reiterated that custom colour should only be used if absolutely necessary, as the system can become much more sensitive when in the custom colour mode. It may be worth considering use of a near-infrared camera instead, as it reduces the requirement for operator fine adjustment of custom colour, and the camera is also recognised by the system. The light bulb symbol indicates that night operation lights are fitted. Touching on the symbol turns the lights on and changes the symbol to a yellow colour. Touching again turns the lights off. An optional fine offset tool, which adds a flip touch button under the fine offset bar, when touched flips between two different fine offset values. This is useful whenever bias regularly alternates between two states, for example when working on side slopes or in tall crops blown by a crosswind. If side slope compensation has been activated and the camera skew has settled, this symbol will appear indicating that the system is ready for automatically compensating for side slopes. When compensation is taking place, the orientation of the tractor should match the direction of the slope that is being compensated for. Where multiple cameras are fitted, each will have a live video thumbnail at the top of the screen. The currently selected camera will be shown in the larger live camera view. When multiple cameras guide a section, they work together. Whichever camera is selected for live view does not change priority or weighting of the camera information. Briefly touching on a thumbnail selects that image for the main display. Briefly touching on the main video image switches to a full screen video mode. Guidance continues in this mode, but the information symbols, speed, position indicator, etc. are obscured. Touching again reverts to a normal image size. Touching and holding on an image or its thumbnail stops images from that camera being used for guidance, making guidance solely reliant on any remaining cameras. When a camera is disabled in this way, a red cross is superimposed over the image which remains live. Touching and holding again restores normal function. The Auto Learn feature incorporates machine learning techniques to better match crop template and actual crop rows. A better template match results in better performance. Briefly touching on the Auto Learn button prompts the guidance system to slightly re-evaluate template match and automatically adjust camera height and look ahead to better align crop and template. This prompt only applies to the currently selected camera view. To perform minor template adjustment to another camera, select that camera and briefly touch the Auto Learn button. This tool is intended to improve template match following initial camera setup, or to compensate for variations in crop height, or implement position and therefore camera geometry when in the working mode. Touching and holding on the Auto Learn button will bring up the Auto Learn parameters pop-up screen. Bear in mind this screen is only accessible when the system is in work but stationary or in the lifted position. The Learn parameters for each camera can be viewed and reset from this screen. The first two columns of learned camera parameters are height and look ahead as per the diagram on the right. Height being measured from the ground level to the camera lens, and look ahead being the forward angle to the centre of the field of view as depicted by the blue crosshairs when the guidance system is in manual mode. Automatic learning of these parameters can be turned off using the touch toggle, which will disable or enable automatic adjustment of camera height and look ahead. The third column of learnt camera parameters is skew. Camera skew is the angular misalignment in the horizontal plane which is learned during the initial running or after skew has been reset. It compensates for minor misalignment up to about 3 degrees. It has been exaggerated in this slide for illustration. It converges to a stable value after about 100 meters of running. It is good practice to make this initial run on a flat field of crop with well-defined crop rows, so that the value learned is as accurate as possible. Automatically learning camera alignment to a high precision in this way increases acceptable mechanical tolerances without sacrificing tracking performance. A camera skew greater than 3 degrees is not acceptable, and its causes should be investigated. If a machine has multiple cameras, each camera will learn its own skew value. The fourth column of camera offset is only applicable in the case of multiple cameras mounted to a single section. The offset parameter is the lateral misalignment between the left-hand camera and any other cameras mounted on the same section. The left-hand camera defines the datum, and the other cameras use that to calculate offset. Like skew, it's learnt in the first few meters of running and converges to a stable value after about 100 meters. The learn parameters should only be reset if you have made mechanical changes that may have affected the values. Estimation of camera skew and offset is mandatory, indicated by the always on text. For multiple camera implements, each line represents the learn parameters for each camera. The symbols shown next to the learnt parameter relate to the current state of that parameter. An open padlock indicates that the parameter has some level of flexibility to better match their actual figure. A closed padlock indicates that the parameter has converged to its actual or learnt value, or that the auto learning feature has been toggled to the off position, thereby locking the parameter to the currently displayed value. Pressing the reset button will revert the parameter to the value set within the configuration file, which will leave the auto learning free to learn new values. Once the system has run within crop for a period of time, the automatic learnt parameters of skew and look ahead will become effectively fixed, depicted by the locked padlock. Bear in mind this typically only requires approximately 100 meters for this to occur. Resetting of skew and offset should only need to be performed if adjustment of camera mounting has occurred, and should not need to be regularly pressed. Upon being reset, the padlock unlocks and the parameters are free to be calculated by the auto-learn. We recommend setting up camera geometry and template match as best possible in order for automatic learning to have the best chance of converging to correct parameters. Major resetting of learned parameters should only be needed when changes to camera geometry have occurred. It is best practice to set crop height to the appropriate range within the setup page to match actual crop height. Pressing of the Auto Learn button while in work if you think template match could be improved is normal, and should add enough flexibility to account for variations in crop height, implement settling into work, changing wheel depth, etc., but should not be pressed if the implement is travelling around a corner, or if crop has failed, as this may lead to the system learning incorrect values. Returning to the working screen, to access the setup screen, press the button labelled with a spanner. From this screen, the user can identify the currently selected configuration and can also select from the list of preloaded configurations, which may be different to suit the different crop and machine geometries. Pressing on the configuration button will give the user a drop-down menu from which they can select a suitable configuration file. Camera and crop setup parameters are displayed here, this information being useful for initial setting up of cameras. The number of rows and the spacing between the rows to be tracked by the selected camera. This should match the crop pattern the guidance system is to work within. The camera height as set in the configuration file and the correction applied in brackets by the auto learning of camera height is shown here. Similarly, camera look ahead and the applied correction. The distance between the camera and the cultivators. Crop height should be set to suit the height of the crop in the field. Press on the Crop Height button to select a crop height category from the drop-down menu. Adjustment of crop height is to accommodate for the change in perspective that occurs when a crop grows closer to the camera. 3 categories of small, medium and large can be selected. The sizing of these categories scales with camera height. Select an appropriate height that best suits the crop in the field. To access the Advanced Settings and Diagnostics screen, press the button labelled with a spanner ++ symbol. This screen provides system information, diagnostics tests and options to change more advanced settings. Information includes software version, total running time and area covered since new, a resettable time and area meter, the steering test, which is an interactive test that checks for position sensor and hydraulic flow polarity. It also checks for lateral speed and will report if it is too fast or too slow, as well as reporting if full movement cannot be achieved. Once initiated, you simply follow the on-screen instructions. Note direction related prompts should be in relation to the direction of travel. If proportional valves are fitted, the test performs additional movements that calibrate lateral speed as well as checking if sufficient oil flow is available for peak steering speed. There is also the option for a purge steer function, which will drive steering cylinders to their end stops for 10 seconds each way, to expel air from steering circuits or to provide registration between cylinders. From the Advanced Setup and Diagnostics screen, it is also possible to enable some optional features and to change some behaviours. You can select between imperial and metric units. There is a buzzer in the console which can be set to sound an audible warning if the tracking warning is displayed. The default is on. If a machine will be regularly used on side slopes or work within tall crops that might be biased to one side by a crosswind, then it might be worth enabling the fine offset flip option. As we saw in an earlier slide, that adds a touch button to the working screen below the fine offset bar that enables drivers to flip between 2 fine offset values. Side slope compensation is an experimental feature allowing the camera system to automatically compensate for side slopes, reducing the amount of fine offset adjustment required to maintain correct cultivation position. The final item gives you the option to view the error log. If the selected configuration file and applicable hardware allows, 2 extra Isobus related items will be displayed. The threshold for in and out of work position could be set using this utility. Touching on the Adjust button will open the Isobus Hitch Setpoint utility. That displays a live position bar of the selected hitch or hitches' current positions. If you adjust the hitch using the tractor controls to the desired position, and press the Set button, this will change the hitch threshold set point to the current hitch position. The second utility is the Isobus Diagnostics tool for viewing device address information, status and errors. Touching on the View button will open this utility and enable the user to view the live Isobus CAN status for various tractor-related messages, as well as all Isobus devices that are connected to the tractor bus. Pages can be scrolled through using the arrow buttons. It is also possible to take a 20 MB log of the Isobus data traffic to a USB device, useful for remote diagnostics. The system may retain its settings if power is interrupted, but like any computer, it is much safer to power down properly. In this case by using the power down button on the home screen. From any of the setup screens, press the loopback button to return to the working screen. From the working screen, press the home button to return to the home screen, where you can press the bottom right power down button, saving all settings and logs from that session. We hope that you have found this presentation useful. Remember that it is part of a series of 6 videos that you can select from our website and view them as many times as you want. Our website also has links to other reference and training material, including full reference manuals in a variety of languages. If you have any questions, please get in touch. Thanks for watching.